In this section, the best way is to like just do the examples, like talking through it and like talking out like the basics and what's happening isn't really as easy as just like Nike, like let's just do the problems. Okay. Again, a lot of this stuff is going to be review. It's going to be stuff that you've seen before in other classes. So just kind of go back and try to remember and fine tune these skills. If there's a minus in between two sets of parentheses, it's not asking me to like FOIL it all out. What's it asking me to do? Subtract. So I would probably do this problem in 2 steps to avoid making a mistake. If you could do it in 1, that's fine, but I would probably go with 2 steps. So my first parenthesis stays exactly as it is. And then my second parenthesis, all the signs are going to switch to the opposite of what they were with that negative. So for some of these problems, like I said, we're just really going back and we're adding and subtracting like terms and we're thinking about those ideas. I've got something cubed and something cubed. Those are like terms. Do I have anybody else being squared? Anybody? I don't see one. And then I've got some terms like this with just an x to the first power. And then I've got this one that is just a number. So I like to go through visually and like identify for myself which ones are like terms. If you like that strategy, do it. If you don't, don't. Again, it's up to you. You haven't gotten to pre-calc by chance, right? Like you got some skills. So whatever works best for you. So 4x cubed minus 5x cubed gives me what? Negative 1x cubed. I've got just my negative 5x squared. It unfortunately doesn't have a buddy. How many x's? 2. And then the 12 also doesn't have a buddy. So this will be my final answer. Again, consider boxing in final answers. The more work you do, the more beneficial it is for me to like see, okay, what is your final answer. Number 2. Sorry, I knew that was coming. Also, I'm a loud sneezer. I can't remember if I've already told you that, but just be advised. All right. For problems like number 2, the way I think of it is almost like double distributing. So what I like to do is send through the first thing, and then I go back and I take care of the second thing. So everybody's getting an x the first time through. So instead of 2x squared, now I'm at 2x cubed. Now I'm at 4x squared. Now I'm at negative 10x. Another way that you can set these up instead of having it all be horizontal and like underlining and circling stuff is you can position things above and below each other to help yourself as well. So when I multiply here, I get 4x squared, and I'm going to put that right underneath the other x squared term. That's going to make my life easier in a second. Here is a 16x, and here is a negative 40. So again, you can set it up vertically as well if you want. What did I do? What did I, oh, 8x squared? Oh yeah, it sure is. I multiplied but did not actually multiply. So 4 times 2 should be 8x squared. Thank you. Transition that over. Here we go. 2x cubed plus nothing, 2x cubed. Here's a 12x squared, a 6x, and a minus 40. So this would be my final answer. What is it telling me to do if it's telling me to square this? What is it doing? What am I doing? I'm going to work over here where I have more space. What is it asking me to do? I feel like I hear some rumbling. Multiply it by itself, right? If it was cubed, how many times would I multiply it by itself? 3. But it's being squared, so I'm going to multiply it by itself twice. So do the same thing we just did, and go ahead and multiply it out, and we'll check back in and make sure we're at the same spot. If you can do the last one, you can definitely do this one. should have got x squared plus 10x plus 25. Good? And the next one's a little bit trickier. We've still got multiplication, so we're still using that same skill set, but now we've got some roots in there. So that's something new. Here we go. Let's send them through just like we would have before. 2x times 2x, 4x squared. 2x times root y is going to be positive 2x root y. Here's a negative 2x root y. And then a negative times a positive is a negative. And this is going to be the square root of y squared. Let's tidy this up. What happens to my middle two terms? Gone. I love it when stuff cancels. It's my favorite. So I've got 4x squared minus, what is this going to simplify to? Y. So that simplified down real nice, especially with where we started. Ooh, here come the factoring ones. This is why we had to do this stuff yesterday. And again, the solving with the factoring is coming too. Alright. Look at it and think about what type it is. What do you want to use on this one? Difference of squares is my strategy. 2 sets of parentheses. If I square root 25x squared, what do I get? 5x. So I'm going to put that in the first spot in both. I'm going to throw a plus in one, a minus in the other. Doesn't matter which is which. Square root of 81? 9. Okay. Next one. Looks a little bit trickier. But what is it? When you boil it down, which type? Do I have a perfect square right here? Do I have a perfect square right here? Do I have a difference? So it's a difference of perfect squares, believe it or not. So I'm going to use some brackets to help myself kind of section this off a little bit better. I'm going to put a plus in one, and I'm going to put a minus in the other. Notice that it's a little bit pivoted to the right, so that way I can fit some more things in it. If I square root this first term, this is my first term, what would the square root be? X plus y. I'm just going to keep that in parentheses. You could do it without parentheses, but I just kind of like to keep it grouped together. And then what's the square root of z squared? Z. So this would be my answer. So again, we're kind of taking some of those basic skills that we were looking at yesterday, and we're looking at some trickier and trickier problems. Like I said, the good news is when we get into solving, solving is really the goal, and so some of these get a little bit easier. Ooh, trinomial, ready? 2 sets of parentheses, one small, one bigger. What are my signs? Minus, plus, plus. Okay. If it were a sum of cubes, it'd be plus, minus, plus. Now, I'm going to go through and I'm going to take the cubed root of each thing. So that's going to give me 2x and 3. Take the first term and square it. Take the last term and square it. And this is the only time I will say this to you. Multiply them and ignore the fact that there's a negative. So it'll be 6x. Again, this gives you a trinomial. I get that. I agree with you. They can never be factored further. It's just how they're set up. It can never happen. Okay? So even if you're tempted, don't be. It's not going to work. Okay. Next one. That one looks like a difference of cubes too, doesn't it? Yeah. Let's deal with difference of cubes again. So we've got one set of parentheses for one small, then one set of parentheses that's going to be bigger. We've got minus, plus, plus this time for our symbols, same as the last time. Alright, so the first thing we need to think about is what is the cubed root of x to the 6th? Remember what this is. What am I going to get? X squared. What's the cubed root of 1,000? 10. Take the first term and square it. Take the last term and square it. And then multiply them together. next one I know you can do. You don't even have to turn on your brain much. You can do that one. Do the next one on your own. And now at the beginning of the year, it's a good time to remind you that, again, always simplify things as much as you can, whether it's a fraction, whether it's a set of parentheses. So yes, this will be x plus 7 twice, but this is more simplified for me to say it's x plus 7 squared. All right, number 10, looks like it could be a difference of squares, but it's not really because 8 isn't a perfect square, neither is 2. So what I'm going to do first is pull out what they have in common. What can divide evenly into both? 2, and then, yep, I agree with the x squared as well. We can also take that with it. Let's see what's left over. I'm going to have an x squared minus 4. Can I continue to factor? Yeah. Yep. So make sure you don't just factor once and call it a day. Again, just like I said, always simplify all the way. Always factor all the way as well. Square root of x squared is x. Square root of 4 is 2. Plus in 1 minus in the other. Okay. We've got 2 more. The trickier ones are on the next page. Alright. So, friendly reminder, when you're multiplying two things together, like x cubed and x squared, what do I do with those? I add them together. So we're going to use that idea in just a minute with this one. So I can't do anything as it stands with a trinomial at the moment. There's too much it looks awful, doesn't it? So let's try to make it look a little bit better. And a lot of times in math, that's a skill we need to have. Is like, this doesn't look like something I can deal with. Let me try to make it look like something I can deal with. Similar to the problems where you pull out an x squared if it's the lowest exponent. I'm looking for the lowest exponent. What is it? 1/2, but not just 1/2. Negative 1/2. So I'm going to pull out a negative 1/2. What number divides evenly into all of these? 3. So I'm going to pull out a 3 and a negative 1/2. Now remember, when you go to find what is left over in this parentheses, this is going to get added to this to get that. Okay? So we're looking for addition. So 3 times what is 3? Just a 1, right? And then x to the, so we need something here that when we subtract a half will get me to 3 halves. What would that be? Squared, right? So squared would be the same as 4 over 2. If I have 4 over 2 minus 1, does that get me back to 3 over 2? Sure does. Okay. Next, I need a minus. 3 times what is 9? 3. Okay. Those aren't a match. They're close, but they're not a match. I definitely need an x here. Let's think about the exponent. I need this plus something to give me this. What do I need here? Just an x, right? An x to the first, because 1 and then subtract the 1/2 should get me back to 1/2. And then these are already a match, so I just need to think about 3 times what is this? 2. So yes, this was a little ugly to begin with. However, now it looks a lot better. So always make sure that if you come across a problem and you're like, oh gosh, that you try to turn it into something that wouldn't make you say, oh gosh. Okay, do you see how we have a trinomial here? We can factor that one step further. What am I going to get? What 2 sets of parentheses? X minus 2 and x minus 1. So that'll multiply to positive 1 and add to negative 3. Nice. Factor by grouping. Here we go. I think this one's pretty obvious, right? Some of them aren't as obvious. This one's very obvious. Again, you're grouping by stuff they have in common. So I'm going to group these two because they both have a ton of x's. I'm going to group these two because they both have some 4's. So I'm going to start here, and I'm going to pull out what? X squared, and I'll be left with what? You got it. What am I going to take out here? 4, and I'll be left with x plus 1. So again, we think of these as two separate terms, term 1 and term 2. What do term 1 and term 2 have in common? So I'm going to pull an x plus 1 out front because they have that in common. What are my leftovers? X squared plus 4. Now, if we were factoring over the set of real numbers, which we are, I would say, ooh, I'm done. Do you know how to factor it further if it's imaginary? Ooh, you don't? Okay. You ready? Let's go further. Let's pretend. X plus 1, we can factor this further. It factors into two sets of parentheses. So a sum of squares is super similar to a difference of squares. So you're going to take the square root of the first term. Square root of x squared is x. You're going to take the square root of the second term. Square root of 4 is 2. You're going to put a plus in one and a minus in the other. But notice what would happen here. Do you see how the 2 times the negative 2 would give me a negative 4? So you start thinking like, okay, I need to change the sign. How can I change it to a positive? I. So now you would still get 2ix minus 2ix. So those would still cancel like you want them to. You'd get x squared, but this is going to be minus 4i squared. And what is negative 4i squared really? Negative 4. Or positive 4. Sorry. Positive 4. It was negative, now it's positive. So that's how we get back to this. So if you are factoring over the set of reals, you're done here. If you're factoring completely, then you'd be done here. For me right now, you can stop here. If you want to go the extra mile, you always can. Okay. I find that the first quiz gets a little bit stressful for people. Because it's pre-calc, because it's math, because it's a new year, because you've never had me as a teacher before, like we could make a long list of reasons. So we're going to review tomorrow and again on Tuesday. I don't normally review 2 days before a quiz. That's not a normal thing that I'll do the rest of the year. But I like to before the first quiz to make sure you're good and ready and comfortable to do the quiz. So we'll review tomorrow. We're going to review again on Tuesday, and then we will quiz on Wednesday next week. Again, no school on Monday. Homework for tonight is going to be more problems like this, where you're multiplying, where you're factoring. You could have some rational exponents like number 11, so they can get a little tricky. This is assignment number 4. Again, I count up. I start fresh with each new chapter. Otherwise, when you get to like assignment number 150, you're kind of like, oh my. This is what I've done with my life this year. So we're not going to do that, but we'll start fresh every chapter and we'll count up. So this is assignment number 4. We're going to do page 32 to 33. You've got lots of time right now. This doesn't always happen, so enjoy it. The problems are, there's a smattering of problems because I wanted you to do at least one of each without making you do a ton. One thing you will notice about me as a teacher is that I would rather, like I still want you to practice, but I don't find a benefit in having you do a million problems.